In this module, I'm going to introduce the muscle control formula, and then I will give you an example using a concentric muscle action. To start, let's go over the 6 steps of the muscle control formula. Step 1 is to identify the joint movement or position. Step 2 is to identify the effect of the external force on the joint movement or position. Step number 3 is to identify the type of MTC action, either concentric, eccentric, or isometric. Step number 4 is to identify the plane of movement and the axis of rotation. Step number 5 is to identify on which side of the joint axis the MTCs are lengthening and on which side the MTCs are shortening. And finally, in step 6, you will identify which MTCs must be producing or controlling the movement or position. Step 1 is to identify the joint movement or position. Let's illustrate this with an example. In this case here, you see that we have glenohumeral abduction. So we start at position A and we move to position B. We ID the joint motion as being abduction, or looking at it from our perspective here, we see that we have a clockwise rotation of the humerus. Step 2 is to identify the effect of the external force on the joint movement or position. In this case, we ask ourselves, what movement would the external force produce if there were no active muscles? In this example here, going from position A to position B, the external force would be gravity. We can see gravity would want to rotate the arm downward. So identifying the effect of the external force would be adduction, or from our perspective here, we'd be looking at a counterclockwise rotation. Step number 3 is to identify the type of MTC action, be it concentric, eccentric, or isometric. In order to identify the type of MTC action, let's go through a decision flowchart. First, we want to identify the joint motion and the effect of the external force. Next, we need to establish the movement direction. We want to establish that movement direction in relation to the external force. So in one case, we can say the joint movement and the effect of the external force are going to be in opposite directions, or we can say that the joint motion and the effect of the external force are going to be in the same direction. If the joint motion and the effect of the external force are in opposite directions, we will have a concentric action. If the joint motion and the effect of the external force are in the same direction, then we have to ask ourselves another question. We have to determine the movement speed. And in this case, we would have to ask ourselves, would the joint motion be faster or slower than if there was only the external force? If the joint motion was faster, then we would have a concentric muscle action. If the joint motion was slower than that which was produced by the external force, then we would have an eccentric muscle action. Now we have to ask ourselves what would happen if we had no movement at all. In such instances, we would have an isometric MTC action. Finally, the joint movement could be across the external resistance. In other words, they're occurring in different planes. In such cases, the MTC action would be concentric. So now, let's return back to our example of glenohumeral abduction. Again, we are going to go from A to B. We see the joint motion is going to be abduction, or in the clockwise direction, and the effect of the external force is going to be adduction, or in the counterclockwise direction. In terms of identifying the MTC action, we note that the joint motion and the effect of the external force are in opposite directions, so we conclude that we have a concentric MTC action. Next, we need to identify the plane of movement and the axis of rotation. Again, as we go from A to B, we note that we have glenohumeral abduction that's occurring. So our axis is going to be an anterior-posterior axis that goes through the head of the humerus. And the motions of ab and adduction occur in the frontal plane. For step 5, we have to identify which side of the joint axis the MTCs are lengthening and on which side the MTCs are shortening. Again, as the joint motion goes from A to B, we're going to have muscles on one side that are going to be shortening and one side that's going to be lengthening. In this case, it's going to be easier to illustrate the MTCs that are acting on the medial side. Demonstrated here in blue, you can see that we go from A to B. Going from A to B, we see that the muscles on the medial side are lengthening. So that means the muscles on the lateral side are shortening, which are the abductors, which again are harder to illustrate in this example. But we can clearly see the MTCs that are lengthening are going to be on the medial side, which are the adductors. Our final step is to identify which MTCs must be producing or controlling the movement or position. Again, as we go from A to B, we note that the MTC action was concentric. And when we have a concentric MTC action, the MTCs that are shortening are controlling the movement. And in this case, the MTCs that are shortening are going to be the ones that are on the lateral side of the joint, or the glenohumeral abductors. So let's review what we did here. In step 1, we identified the joint movement or position. In this case, we determined that the joint motion was glenohumeral abduction. Step 2 was to identify the effect of the external force on the joint movement or position. What would happen if only the external force was acting on the joint? In this case, we determined that the force due to gravity would adduct the glenohumeral joint. Step 3 was to identify the type of MTC action, either concentric, eccentric, or isometric. In this case, we determined that the joint motion was glenohumeral abduction, and the effect of gravity would be to adduct the glenohumeral joint. Since the joint motion and the effect of the external force were in opposite directions, we conclude that this was a concentric MTC action. Step number 4 was to identify the plane of movement and the axis of rotation. For glenohumeral ab and adduction, we identified that the axis of rotation was an anterior-posterior axis that went through the humeral head, and that the plane of movement for glenohumeral ab and adduction was in the frontal plane. Step 5 was to identify on which side of the joint axis the MTCs are lengthening and on which side the MTCs were shortening. And we determined that the MTCs on the lateral side, the glenohumeral abductors, were shortening, and the MTCs on the medial side, the glenohumeral adductors, were lengthening. Finally, step 6 was to identify which MTCs must be producing or controlling the movement or position. Since we identified the MTC action was concentric, we know that the MTCs that are shortening must be producing or controlling the movement. In this case, it would be the glenohumeral abductors.